Hi, this is another example of function operations, and in this case I have to make this operation here on the center on the left, f times g times h of x. Now here I have the functions f, g, and h, here, here, and here, and I already written here the domains of each of them. Just before going to do the actual operation here, we have to get the domains of the function involved, the functions involved. And just they're actually pretty much the same functions from the previous example, exactly the same function of g of x and h of x from the previous one. Just f of x is changing a bit. I'm adding up here this term of 3 times x next to the square root. I'm going to tell you why later. But actually this 3 times x multiplying, it doesn't affect anything to the domain of f of x. It just stands the same as -4 included until positive infinite. So I'm going to proceed to do the actual operation of f of x times g of x over h of x. In the center here, I'm going to write here each of the operations, the functions. I'm going to write here my long line here. And here we have my 3 times x times the square root of x plus 4. And here I'm going to place the g of x here, would be 1 over x minus 5, this is an x here. And the denominator, I'm going to place the h of x, which is going to use here 3 times x over x minus 2. I'm just going to write here this first term in yellow, it's all over 1, just to make clear what I'm doing here. And this will be multiplying 1 over x plus minus 5. Now here comes the thing, before going any further, every time we have a division of functions, the function that is in the denominator, in this case h of x, cannot be equal to 0. So I'm going to write it in here, big red here. H of x has to be different from 0. Now we have to make sure that all of it as a whole, h of x, cannot be converted into a 0 in any part of it, because if we would allow this, we would accept the value that would convert this operation into a non-defined situation, because we get a division over 0. So we have to make sure that all of the parts of h of x cannot be converted to a 0, we cannot accept a 0. We have already taken this x minus 2 in here, so there's no point just to repeat that process here. But here comes the thing, this 3 times x, we haven't considered the possibility of what would happen if the 3 times x gets converted into a 0. So I'm going to include it as a restriction, just like in here. I'm going to include this 3 times x and we'll make it different from 0. So here I'm going to divide by 3 in both sides of the equation, and here we will have on the right 0 over 3, and we will get to x different from 0. So we have to keep in mind this statement here until the end when we write the final domain. I'm just going to proceed from here to do actually the algebra of this statement here. It will be here 3 times x times the square root of x plus 4, and this will be divided over x minus 5, and this will be all divided over 3 times x over x minus 2. So here we have to use the super famous sandwich rule, multiplying these 2 and these 2, and we'll get to this statement here on the right, which I'm going to write here, will be 3 times x times x minus 2 times the square root of x plus 4. I'm going to stretch this a bit here, and in the denominator we will have this 3 times x minus 5. And here we can actually cancel out something. We can cancel out this 3 times x in here. We can cancel out these two, which is perfectly fine, and we'll get to this statement at the end. Would be x minus 2 times x, the square root of x plus 4 all over x minus 5. Now if we look at this last statement, we would see that the only restriction we have here is this, well, of course, outside of the root, this x plus 4, but this x plus 4 is just the same as the one from f of x from here. I'm just going to rewrite it here just to make it clear everything out. Here will be x plus 4 greater or equal than 0, so x will be greater or equal than -4. I'm just doing here all the steps so you have all of it properly. You feel free to skip some obvious things, perhaps because this x minus 5 we have to as well, you know, make it x minus 5 different from 0, and here will be x different from 5, which this x different from 5 is already included here in the domain of G. I'm just going to do it all of it just to show you all of the possible steps here, and I will get here to the domain of the operation. It would be f times g, oh, this is too ugly, over h here. And this domain, just by looking at the last statement we have here, it would be only from -4 until 5. Then we use a parenthesis because we're excluding it because of this different from, union 5 to infinite here. That will be just the domain for the final statement, but the actual solution will be different. Now, before writing the final solution, I want to notice something. If we wouldn't have identified this restriction on the beginning, from this part here, we would have canceled out this 3 times x in here and in here, and we wouldn't have included this restriction that x has to be different from 0. That's why it's very important that every time you have a division, you start by noticing out that what's in the denominator has to be different from 0 as a whole. All of it has to be different from 0. So, well, luckily we did it on time. We found that x has to be different from 0, and I'm just going to write here the final domain. I'm just going to write here big D, and this would be including all the restrictions here. It would be, okay, something like this, from -4, including the -4 we use in this bracket here, until the 0. We're excluding the 0 here, so make a union, then 0, and will be until the number 2 here. We use the parentheses, we use the union because we're excluding just the 2 because of this restriction here. Then we continue, we continue here 2 until 5. Again, we are excluding the number 5 for this condition and from here as well. Then we close the parentheses, we make a union, then 5 to positive infinite, and that would be the final domain of this expression. Just want you to say again, make sure to identify any possible restriction from this statement. The one in the denominator has to be different from 0, because you could have on the way cases such as this one, that you cancel out the term that would produce a restriction. So I guess that would be pretty much all of it for this example.